Okay, hello, Assalamualaikum, and good afternoon. Okay, somebody can respond to me whether you can hear me or not.
Waalaikumsalam, Doktor.
Okay, good. So, welcome back from your holiday. Okay, so make sure you are in the correct class, Introduction to Scientific Programming for Section 1 and Section 2. Okay, so let us start with the Chapter 0, just an introduction on the CI. Okay, course information. You can download it in e-learning. Okay, here is the course information, or you can just download the simplified version. Okay, this one. Okay, so this is my contact. You can go to my office at P19A 040327, or you can contact me via Telegram. Okay, or you can email me here. Okay, so this is the standard policy for this course. Attendance is compulsory. You must attend 80% of the lecture hour, okay, to eligible to the final exam. This is the standard, okay. This is the UTM policy. Okay, you are responsible for whatever is taught in the lecture. If you miss the class, you are responsible to find out about assignment, quizzes, and exam. Okay, punctuality is expected. Makeup test will not be given except in the case of actual emergency with written evidence. Okay, okay. Only medical certificate from UTM is accepted, and you are encouraged to collaborate and not copy. Okay. So for these courses, okay, you have 50% coursework and 50% final exam. Okay, for tests, you only have one test only. Okay, and the test cover 20%. So make sure you have to prepare for your test. Okay, because the mark is quite large. And you have to save the date. Okay, 21 April 2022 at 4 p.m. This is on, if not mistaken, on Thursday. Okay, so make sure you save the date and make sure you come. Okay, if you cannot come, as I mentioned before, you need to give the written evidence. Okay, this one is important because usually if you don't have good exception, okay, this will be 0. Okay, test 1 will be 0 and you will lose 20%. Okay, for quiz, you have quiz 1 and quiz 2. This one will be announced later. Okay, for the group assignment, okay, so the group assignment will be done in group. Okay, so this one is 20%, and the date I will set it up around week 10. Okay, and of course the final exam. And also for test 1, okay, make sure this is only cover for chapter 1 until chapter 4. So prepare chapter 1 until chapter 4. And for final, I will announce later what topic will be included in the final. Okay, so we move on to this course will introduce the fundamental of the scientific programming language and technique used by engineer to solve the engineering problem. Common scientific programming language and their advantage and disadvantage, programming design, scientific computing tools, techniques, implement algorithm, and so on. This one is just a overall, okay, the summary, what will you learn in this course. Okay, so prerequisition, before you can enter this, you need to know what is the basic operation of computer, and of course you need to know basic math. Okay, so this is your course learning outcome. Okay, you have to know how to apply knowledge of scientific programming, describe complex engineering program in the flowchart, pseudocode, and program. Okay, and for CLO2, apply concept of scientific programming to solve complex engineering problem. Okay, and CO3, analyze and apply the advanced program scientific language. Okay, so this is the CLO for the course. Okay, and for the course outline, you can see here, you have 14 chapter. Okay, so there is a lot of chapter. Basically, one chapter for each week. Okay, so you will have a mid-semester break at week 7. Okay, and for test 1 only cover until control flow, week 4. Okay, I think some of the chapter we will finish early. Okay, because if we finish at week 15, it's quite late. Okay, and usually I will not available at week 15. Okay, so all of these are the coding that you will learn from in the MATLAB. Okay, and lastly, okay, the reference. This is the textbook. If you don't prefer to use the slideshow, okay, the lecture note, okay, you can download the textbook. You can see here I also include the textbook. Okay, so this is the textbook. I suggest you don't use the textbook because it is much more complicated and you can get confused. So better stick to the lecture note, and the question usually will be based on the lecture note. Okay, so this is the e-learning. Okay, you have the classroom, the group, Telegram group, and of course you have to install software. Okay, so because this is a scientific programming class, you need to install MATLAB. Okay, for MATLAB, okay, wait, I have to move the WebEx. Okay, so for the MATLAB, actually UTM already provide you with MATLAB. You don't have to buy it yourself. Original MATLAB can cost around maybe 5,000 ringgit to 10,000 ringgit. Okay, so no need to buy the original one. Okay, but you can download the UTM version. You go to my UTM portal and go to digital experience software, and then you can look at the MATLAB. So this is the explanation. You can just register it. Okay, so that is how you get the software. Okay, make sure you download MATLAB for the next class. Okay, in the class you have to try every code that I show. Okay, that is the better way to learn about the scientific programming. Okay, if you just look at the language, okay, you look at the slide, you cannot easily understand it. But if you practice it in the MATLAB, okay, you can easily understand it. Okay, so this is the required software. Okay, this one required software. Or if you don't want to use UTM MATLAB, because MATLAB is actually more than 10 gigabyte, okay, you can download Octave. It is just an alternative. Okay, the size is only 322 megabyte. It is much more smaller, so you can save a lot of data, but this one is not it's still almost the same. Okay, the coding is almost the same, but it's not the same as the MATLAB. Okay, because the node is mostly follows MATLAB. Okay, so this is MATLAB. Okay, for those who you do never see MATLAB. Okay, this is MATLAB. Okay. It's quite heavy. When you install the MATLAB, make sure your computer is compatible. Okay. Okay, this is MATLAB. Okay, this is the interface. I will show you later. Okay, so for right now, we start with chapter 1. Okay, let me show you chapter 1. Okay, basically chapter 1 is just an overview of programming language. So we will not start using the MATLAB yet. Okay, we will start using the MATLAB for the next week. Okay, so we continue with the first chapter. Okay, the overview of the programming language. Okay, this is mostly on the theoretical. Okay, I will not go more in detail for this. This one is just more towards you just memorize it. Okay, so if you're in the test or in the final exam, the definition and everything, this one advantage, disadvantage, this one you have to memorize. Okay, there is no other way to answer this. Okay, so first of all, let's define a computer. Okay, computer is a programmable electrical device that can store, retrieve, and process data. So that is what is computer. And what is program? It is much behavior is characterized by the logical sequence. Okay, program is just a logical sequence. For example, turning a page by hand. So when you want to turn a page of book by hand, there will be a sequence, okay, logical sequence, lift hand, move hand, okay, press the top corner and move the hand to the left, from left to right, okay, right to left, okay, let go of the page. Okay, this one is just a sequence, okay, logical sequence. So this is basically what is program. Okay, it's just a logical sequence. Okay, what is program? Continue. Many things are done in a certain order of sequence. Walking, okay, this is example. Solving mathematical problem, describing order of sequence of operation of program is called programming. Okay, so if you want to describe the order of the logical sequence, it is called programming, and you will learn about this, how to make a program. Okay, so what is computer program? It is a list of sequence or step of computer performed to solve a problem. Okay, same here, logical sequence, but used by computer. Okay, next, program development. A computer is not intelligent. It cannot analyze problem and come out with a solution. Okay, so this is just a general thing. Okay, I think you understand this. Okay, and human must analyze the problem, develop the sequence step to solve the problem. Okay, and describe this problem to the describe this step into the computer. So this one, what it calls programmer. Okay, why we use the computer? Of course, computer can repeat, okay, solution very quickly. Okay, it can perform consistent again and again, and freeze from people repetitive, boring tasks. Okay, so this is the advantage of using computer instead of using human to run the program. Okay, so program developed is in the three-phase process. Okay, so you have three phase. Okay, problem solving, implementation phase, and maintenance phase. So problem solving phase, of course, you have to analyze the problem and then come out with general solution. Okay, or also known as algorithm. And then you have to verify whether the algorithm is accurate or not. Okay, and then after your complete problem solving phase, you have to implement the algorithm you already done into the computer. Okay, so concrete solution, you create an algorithm into a programming language, and then you have to test the programming language, okay, whether it has a correct result or not. So this is the second phase of the programming. Okay, and the last phase is the maintenance phase. Okay, so you have to use the program and maintain, modify it if some change required or there is some error. So basically, this is the programming development phase. So this is another theory again. Okay, so what is algorithm? So I already mentioned before algorithm. Okay, so algorithm is basically just a general solution. Okay, so problem, okay, programming process is begun by first analyzing the problem and develop a general solution. Okay, general solution is called algorithm. Okay, so a computer program and an algorithm look similar because all program are algorithm. Okay, so computer program is basically algorithm. Okay, so I think this one is still understandable. Okay, just memorize. Okay, memorize part of the note. Okay, now you have to understand it a bit. Okay, I give you example of algorithm. Algorithms to start a car key. So this one is called the list of step. Okay, you can see here algorithm to start the car. So you have to insert the key, press the brake pedal, make sure it is in park or neutral, turn the key into start position, start. If the engine start within 6 seconds, release the key. If engine doesn't start, repeat. Okay. If car doesn't start, call the, I think this one is the workshop. Okay. So basically this step, okay, you can see here is just a logical step. Okay. What you have to do after this happen and this happen. So this is called an algorithm. Okay. When you want to do a program in the computer, you have to know, you have to develop an algorithm first. Okay. So I give you another example of algorithm. Okay. So this is the second algorithm example. Write the algorithm to put a peanut butter and jelly sandwich. So you have to put the bread, peanut butter and jelly, knife and plate into the workspace. Okay. So workspace is basically okay, plate. Easier just say it is a plate. Okay. And then place 2 slices of bread on the plate. Use knife, spread the peanut butter on the side. Okay, on one side. Okay, this one is the standard one. Okay, you know how to make a peanut butter and jelly sandwich. Okay, you have to sometimes repeat step 1, step 2 to step 5. Okay, for each sandwich. And then lastly, eat the sandwich. Okay, so this is also algorithm. So basically, it's just a sequence of logical sequence. Okay. Okay, this one is much more complex algorithm. How to withdraw money from the ATM machine. Okay, the third example. So of course you have to insert the card first, and then you have to insert the password, and then if the password is invalid, okay, display error message and skip to step 6. Means that if your password is invalid, you go to step 6. Okay. Okay, and if it's valid, get the input. Okay, and then you have to choose the type of transition. Okay, get the current balance. I think most of you already know how to use the ATM card. Okay, ATM machine. So this is just a standard way to off the ATM machine algorithm. Okay, if the transition is withdraw, check the current balance. Okay, so if it is greater than the current, if the amount of the withdraw is greater than the balance, skip to step 6. Of course, don't have enough money, you have to end the program. Okay, and if you have more, you have to minus the current balance. Okay, so basically this is a general algorithm. Okay, so what is an algorithm? Okay, so algorithm is just basically an order set of ambiguous executable steps that define a terminating process. So this is the formal definition. Okay. If the question asks you what is the formal definition of the algorithm, this you will give this. Okay. Unambiguously, this one maybe you can Google it. This one means that it doesn't have but double meaning. Okay, or multiple meaning. Okay. Okay. So the characteristic of algorithm. So this one also a theory. If they ask you what is the characteristic of algorithm, you have to know each and every instruction should be precise and unambiguous. Okay, so this one means that don't have double meaning. Okay. What example I should give? Okay. For example, you have a place name called right. Okay, either you go to the right or go to the right. So go to the right means you turn into right side, or you go to the place name right. So that is ambiguous because it has double meaning. So unambiguous means that you cannot, when it comes to algorithm, you cannot have something that have double meaning. Okay, an algorithm should have a finite number of steps. Okay, you cannot create an algorithm that have infinity. Okay, infinity step. It will not end. So when you have algorithm, make sure it has ending. Okay. And of course, algorithm should produce correct result. Okay. When you have the algorithm, you have to make sure you test the algorithm. Okay, make sure it is accurate. And also, algorithm should not use in particular programming language. Okay. So basically, algorithm, if you have algorithm, you cannot focus only on one type of programming language. It can be, the algorithm should be general. It can be implement to multiple programming language. Okay. So make sure you understand all these characteristics. Okay. So next part is how algorithms are described. Okay. So before we continue, let's have a break first, and you can slide in your attendance. Okay. So we will continue back at 2:30. So you can start slide in your attendance. The left side is for section 1 and the right side is for section 2.
It's the same doctor.
Oh, also the same, eh?
Yeah.
Okay, for this week, I think no need, because the system is down, so I cannot do anything about that. Okay, so take a break first. Okay, we will continue back at 2:30. Okay, we continue with the lecture. Okay, so can you hear me? Can somebody respond?
Yes, sir. Can, Doctor.
Okay, good. So we continue. Okay, for this topic, make sure you focus a little bit because many questions ask about this. Okay, and this one is not memorizing topic. This one is more towards application. Okay, means that you need to know how to do this. Okay, so how to describe algorithm. Okay, you have several ways to describe an algorithm. Okay, so the first step, way is by using a step-by-step diagram. So you can see here the origami. Okay, you can see here this is the first step, second step, third step, and so on. So basically, this is a step-by-step diagram. Okay, and this one is not very popular because you can see here you have to draw a lot of things. Okay, can be complicated. So the second one is quite useful. Okay, usually in research paper or many of the algorithm description, we use a flowchart. Okay, I will show you how to draw the flowchart later. Okay, so basically this is the flowchart you can see here. Lamp doesn't work. Okay, it start with lamp doesn't work, and then is the lamp plug in? If no, okay, plug in the lamp. If yes, bulb burn out. If yes, replace with the bulb. Okay, so replace bulb, or if no, replace lamp. So this is the flow chart. You can see here, this is the decision whether it is yes or no, yes and no. And just for your information, this flow chart is not accurate. Okay, I will show you later why this flow chart is not accurate. Okay.
Doctor,
Yes.
I show the flowchart.
What? Yes, I
I-
show. Oh, no flow chart.
Yes.
This one, you don't see the yellow, green, and red?
No.
Okay. Are you see this?
Yes.
Okay. 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 So you don't see the first one, right? This one is the step-by-step diagram. Okay. So this is the flow chart. Okay. So you can see here how the flow chart work. Do you see the mouse?
Yes, Doctor.
See, Doctor.
Okay, good. Okay. So this is the second way to show algorithm. Okay, this is quite popular. Okay, because when you see it, it's easy to understand. Okay. The next one is this one you already looked before. Okay, previously you already looked how to describe the algorithm. The third one is the instruction or list of instruction or list of step. So basically you have a word, okay, step by step. Okay, step 1, what is what? Step 2, step 3, step 4. I think most of you already use this one. Okay, this one is widely used in many things. Okay, it's just a list of instruction or step. That is how you describe algorithm. And the last part, the last way to describe an algorithm is called pseudocode. Okay, so what it means by pseudocode is actually is not a real code. Okay, so when you do programming in MATLAB or FORTRAN or any programming language, you need to follow the what you call the grammar. Okay, you need to make sure the grammar is correct. If the grammar is not correct, the program cannot run. Okay. Okay, what is the difference? That one is the code. Pseudocode don't have that grammar. Okay, so basically you just write a code. Okay, the code doesn't follow any grammar of the programming language. You don't follow the grammar for Fortran. You don't follow C++. You don't follow MATLAB. Okay, you just use a it's like a dummy code, but it's almost close to the real code. So that is what pseudocode is. Okay, and when it comes to pseudocode, okay, make sure that you have to include this one. Okay, procedure, of course, procedure is just you give the name. Okay, you give the name to the program, and then you have to declare the input and the output. Okay, at the top. Okay, declare what is the input, declare what is the output, and usually you have to put double dot here. Okay, for the input and output. And then you have to have a begin and end. Okay, begin and end. And you have usually also you have while or if. Okay, so that is how to do a pseudocode. Okay, why you have to understand all of this way to describe algorithm. Usually you will given for example a list of instruction. You have to do pseudocode, and then you have to do flowchart. Or sometimes they give flowchart, you have to do list of instruction or pseudocode or something like that. So I give you example here. Okay, so this is one of the tests. Okay, this one I forget what year is it. Okay, so you can see here. Okay, parking machine algorithm. So this is the list of instruction method. So the question is A, draw the flowchart and write the pseudocode. Okay, so you can see here this is much more towards a skill. Okay, you have to develop this skill. Okay, step-by-step diagram usually you need to worry. We usually don't test you how to draw. Okay, this is not a drawing class, so no need to worry. But for flowchart and list of instruction and pseudocode, they will ask the question. Okay, so make sure you practice. Okay, this one you can go to, okay, this one in your e-learning. Okay, you can go to the assessment. You can see the previous test example here. Okay, there is a lot of test example you can practice. It will also give the answer. Okay, so this one you need to practice. There is no other way around. And the question is really very large mark. Okay, so I also will give you the previous final exam example. Okay, I still don't, the file is not available yet. Okay, so that is very important because this is very common question will be asked. Actually, it is must-have question. Okay. Okay, before I proceed more towards the pseudocode list of instruction, there is another what you call another theory. Okay, that you need to know. Okay. So aspect of computer and their operation. Okay, a computer typically has a memory, processing unit, and input and output. Okay, this one is quite general. Maybe most of you already know. What is memory? Store information. Okay, RAM, hard drive, flash drive. Processing unit, execute and run program. Okay, CPU, GPU, and input, output, of course. Keyboard, mouse, and printer. This one is just a general aspect of computer. Okay, and then you need to know what is programming language. Okay, so when it comes to programming language, okay, you have a natural language. This one is English, German, okay, example Malay. Okay, that is all natural language. Okay, so for high level language, it's basically C++, Java, Visual Basic, MATLAB. This one is all high level language. It's almost look like English language or natural language, but it's not a real language. It is programmable language. Okay, this is high level language. There is also a low level language. Okay, you can see here low level language. This one usually we don't use it. It is very complicated to program. Okay, usually you will program in a high level language. You have a compiler. Okay, the compiler will convert the high level language into low level English. Okay, and then low level language to the machine code. Okay, machine code is basically 1 and 0. Okay, so this one you don't use this. Okay, you cannot program 1 and 0. Okay, you cannot just put 1 0 1 0 1 0. It's quite hard. So it's usually we use high level language, and sometimes programmer use low level language to program the code. Okay, so make sure you know what is the high level language, what is low level language. Okay. There is also a compiler that can compile high level language to machine language literally. So that one is out of our scope. Okay, no need to worry. So a programming language is simplified form of English with math symbol that adhere to the strict rule of grammatic, strict set of grammatic rule. As I mentioned before, in the pseudocode, sorry, where is it? Okay, as I mentioned before in the pseudocode, okay, pseudocode is basically the programming language that doesn't have grammar. But in the programming language, high-level language, you have a strict set of grammatic rule. You need to follow it. If not, it will error. Okay, the program cannot run. Okay, and then you need to know what is the scientific language. Okay, scientific programming language. Optimized for use of mathematical formula and matrix. Okay, usually programming language are for mathematical formula and metric. Thus, this is more suitable for performing scientific or numerical computing. Math operation can be performed with any programming language. Okay, so example of programming language is available is MATLAB. Of course, in our class we will learn about MATLAB. Okay, and another one is Mathematica. So this one, if you're interested, you can use Mathematica. And then FORTRAN, okay, you can also use it. Okay, so this is the characteristic and the advantages. So you can see here MATLAB is the originally a simple language for metric arithmetic. Okay, it can done most numerical scientific calculation. Okay, very heavily used for scientific and numerical computing. Okay, in research usually people use MATLAB. Okay, research or calculation, okay, use MATLAB. Okay, and MATLAB, the advantage, it has a lot of specialist toolbox. Okay, it has a lot of function you can use. But the problem with MATLAB, it is high in cost. Okay, very expensive. As I mentioned before, it is cost almost 5,000 ringgit to 10,000 ringgit. Okay, but it also have a free version. Okay, you can download the free version Octave. Okay, here you can see here required software. Okay, you can download Octave. Okay, I give you the link. Just download. Okay, if you use Windows, you can download Windows. Okay, this one. So make sure you you download it and install it to your computer because we will learn this next week. Okay, the benefit is easier than other language, easy to prototype. Okay, this is the advantage of MATLAB, easy to program. Okay, next you have Python. Okay, another programming language. Okay, we will not learn about this. Okay, but he only mentioned about this in the class. Okay, a very simple high-level interpret language, much easy and better engineered than most. It is trapped most user in error, including numerical one. Okay, because for best for scripting system interface. Okay, scientific programming is NumPy. This is for software for Python. Okay, unclear whether numerical robust or how reliable is it. Okay, this one it is easy as MATLAB, but if not doing numerical computing, Python is better. Okay, so if you do a mathematical analysis, it's better to use MATLAB. Okay, other than that, it's better to use Python. Okay, this one is quite old. I think some of you already learned about this. Okay, I'm not sure. Okay, C++. Okay, originally from C. Okay, design functioning more than error prevention. Okay, so this is much more towards functionality. Okay, not really good for scientific programming. This one is much more towards to do the hardware. Okay, and the language is quite complicated, hard to learn. Okay, so you need the you need a library. Okay, so if you use MATLAB, you don't need a library because of the program is already there. But if you use C++, you have to import library to do programming. Okay, the advantage of C++ is it is fast, high efficient, and you can create your own data structure. Okay, so of course, last one is FORTRAN, formula translation. Okay, this one is simpler than C++. Okay, powerful. Okay, this one also one is of the oldest. Okay, the advantage is can code in parallel. Okay, you can run the code in parallel. That is the advantages. Usually this one all in series. Okay, and FORTRAN is also portable, high efficient, and support for metrics. Okay, so this one is quite hard to memorize, but try your best to memorize this. Usually we don't ask this because it's quite complicated. So this one easy to use, prototyping, all of this. Okay, which one is better, which one is not. Okay, this one is the different one. Okay, it can run in parallel only on FORTRAN. Okay, so basic programming sequence. So we have to move on to the next part. Okay, now it is more towards application. So the first one is the basic programming is the sequence. So you have a statement 1, statement 2, statement 3. This one is basically step 1, step 2, step 3. So this one is sequence. Okay. Next one is branch or decision. Okay, if your you have a condition, okay, you, for example, if something is something, okay, the condition is true or false, you have one statement and another statement, and then go to the next part. Okay, so this is the second part of the programming. Okay, branching or decision. Okay, so the next part is loop. Okay, so for this one, it is based on the condition. Okay, you have some condition, you have some condition, what will you have to do, what you have to do. But for loop, it is do the same thing over and over again. So the third part of programming is doing a loop. Okay, you have a condition here. For example, you want to check something for a day. Okay, so you have condition check for 24 hours. So you check something. Okay, the statement, the program. Okay, the step. This is the step. So you check. Okay, it's already 24 hours. Not yet. So check back. It's already not 24 hours. Check back until already meet 24 hours. Is go to the next part. So this is the basic programming on the loop. Okay. And another one is subprogram. So subprogram is just you have a main program here. You call another program outside your main program. So basically, how I can give you an example. Okay, maybe this one. Okay, so you want to go from home to office. Okay, so the program is home office. Okay, so your step is, for example, the main program you have go from home to office, but you have to drive to go there, right? So they'll have to call the subprogram, okay? The subprogram that show the step how to drive the car, okay? So that is mean by subprogram. You call another program to run the main program, okay? So you have a subprogram, call the main the main program, call the subprogram, and then after the subprogram finish, go back to the main program. Okay. I think we should break again. Okay. I should okay, I give you 5-minute break. Okay, we continue with the flowchart. How to draw the flowchart. Okay, we continue. Can somebody respond to me whether you can hear me or not?
Can, Doctor.
Yes, we can.
Okay, good. Okay, now we continue with the next part of the programming language, which is much more towards practical than the memorization. Okay, how to create a flowchart. Okay, so when it comes to flowchart, there is several rules that you have to follow. Okay, it's almost like a grammar for the flowchart. Okay, so we start here. Flowchart is a graphical representation of a program solving step that makes clear about the program. So the advantage of the flowchart, it is quite clear. Okay. Type of flowchart are system flowchart. System flowchart give a complete process of mechanism and cannot be converted into program. Okay, this one is flowchart is organization structure. Okay, you usually see this. Okay, this one you cannot convert it into a program because this is just to show the system. Okay. And another one is the program flowchart. This one you can convert to program. Okay. For example, here how to calculate the area of triangle. So there is two types, either system flowchart or program flowchart. Okay, so this is the step that you need to know. Okay. So the important one, the first one is the start and finish. You can see here the oval. Okay, the oval is for start and finish. Okay, and this is important. You can only have one start. Okay, and you can have multiple end. Okay, and make sure your program goes to end. Okay, so for example, if you have a program, okay, so you have a program here. You start with oval. Okay, start. Okay, whatever you do, something like this is always end with end. Okay, you have an oval again, you go to end. Okay, so this is important. Okay, make sure you cannot just leave. Okay, I give you another example here. Okay, so if you have for example a decision here, it goes one here. Okay, it goes one here. Okay, you cannot just leave something like this. Okay, every program needs to start with oval and end with oval. So means that you need to start and end with oval. Okay, make sure you know this. Okay, and don't forget the arrow. Okay, so I repeat again, this one is the common mistake. Okay, every program needs to start with oval and end with oval. You can only have one start, but you can have multiple n. Okay, for example, how to have wait. Okay, and you have go somewhere like this, and then okay, it goes something like this. You can have 2n. Okay, but you can only have one start. And make sure all the program end with oval and start with oval. Okay, so another one is arrow. Okay, for connector, of course, you need to have a direction. Okay, make sure your program have direction. Okay, you cannot just leave something like this. For example, this one, you need to have the direction. Okay, make sure to have the direction. Okay, another important thing. Okay, you already introduced with the start and arrow. Now we start with the program, okay, or process. Okay, if you have a step, for example, calculate or any step that don't have any decision or anything, you have to use a rectangular. Okay, so you can see here. Let me move this. Okay, so of course you have to start with the oval. Okay, you have to calculate what? Calculate something. Okay, so it doesn't have decision because it's just a calculation or step. So you have to use a rectangular. Okay, so rectangular is anything calculate or step you have to take without any calculation, without any decision. Okay, if you have one step, what is it? 2 step, was it 3 step, what is it? And the 4th step, you have a decision. Okay, if, for example, if A is bigger than B, what to do? If B big less than A less than B, what to do? So step 1 to 3 all are what you call the step only. Okay, so you can put all of this in one here. 1, 2, 3. Okay, you don't need to do some. Another one is 2. Another one is 3. Okay, you can just combine it together. Okay, you can do this. It's not wrong, but it's much more tedious. Okay, so you already know the process. Okay, and then you have to know the decision. Okay, this is the decision. Okay, as I mentioned before, if something or something, let me move this. Okay, for example, if you have a start here, okay, and you have some calculation, okay, and then you have a decision, so you have to use this shape. Okay, make sure you use the shape. Okay, the diamond shape. This one is called the branch or decision. Okay, so of course, don't forget the arrow. Okay, and when it comes to decision, you need to have at least two output, true or false. Okay, it doesn't matter where you put it as long as you put it at the different side. Okay, if you don't like left side, you can put here for true. Okay, so you can see here for oval, you can only have one arrow. Okay, in or out. For step or procedure, okay, you need to have 2 arrow, in and out. Okay, you have in and then you have out. Okay, make sure you have in and out. Okay, so for the diamond, okay, the decision, make sure you have 3. Okay, you have one input, 2 output. Okay, 1 input and then you have 2 output, and the 2 output needs to be true or false. Okay, so make sure you know the difference. Okay, so that is the law. And another one is parallelogram. Okay, sorry, I cannot pronounce it. Okay, parallelogram. Okay, so this one is for input and output. Okay, let me move this. Okay, for example, if you have start here, you want the input from the keyboard. For example, enter the name. So you have to draw the parallelogram. Okay, this one. Okay, parallelogram, insert, for example, name. Okay, insert number, insert name, and then you process. Okay, process, calculate or something. Okay, and then you have a decision. Okay, then you have true, you have false. Make sure don't forget about the arrow. Okay, true and false. You have a usually have a procedure here, and then of course remember that I said you need to have an oval. Okay, that is how to do the flowchart. Okay, so you have already know all of this. Okay, the circle as a connector, this one. Okay, usually we don't, sometimes we don't like this. Okay, it's tedious, so we just put a round. Okay, a small round. This one is just a connector. Okay, and of course for input or output. Okay, so for this one is not only input. This one is can be shown as output. Okay, this one have 1 input and 1 output. 1 in, 1 out. Okay, that is the rule to do a flowchart. Okay, so as I mentioned before, the flowchart should have only one start and endings point. Okay, this one already explained. Okay, the flow line should not intersect with each other. So this one you can see here. This one, it doesn't intersect with each other. Okay, this one is just a not intersect. Okay, this is just a connector. Okay, flowchart should not contain the programming language. Okay, when you do a flowchart, usually you don't write the programming language inside here. Okay, commonly we don't write it. Okay, and the flowchart should be neat and clear. Okay, the disadvantage of the flowchart is take a long time to prepare. Okay, you can see here, I have to draw one box, another box, and another box. So it takes a long time to prepare. Okay, and it is hard to translate the flowchart into a program. Okay, so that's why it's better for you to do a pseudocode. Okay, flowchart is good to explain the algorithm, but it's not good to create the program. Okay, so you can see here, you already look at the sandwich. Okay, the example of list of steps of the sandwich you can see here. Let me bring back. No. Okay, so you can see here, this is the list of instruction, one way to explain algorithm, and this is flowchart, another way to explain an algorithm. So basically in your test or final, you have to convert one thing to another. Okay, either it give the flowchart, you have to change the list of step, or another way around, or you have to do a pseudocode. So you can see here, write an algorithm for a peanut butter and jelly. Put the bread, okay, peanut butter, jelly, knife onto a plate. Okay, so basically this is input. Okay, you can see here you have to draw a parallelogram. So get bread, peanut butter, jelly, and plate, because this is input. Okay, place to slice of plate. This one is just a statement. Use knife, spread the peanut butter. Okay, this one you can see here, put knife. Okay, spread the peanut butter. You can either combine it together or separate it. Okay, both are correct, but it's easier just combine it together. Okay, so you can see here if is the conditional. If you want to jelly, use the knife, spread the jelly on the slice. Okay, this is decision. Do you want the jelly? Yes or no? True or false? Okay, spread or jelly. Then go back to the original sequence. Okay, slap the two slices together, stick it in. Okay, this one. So this one repeat step 2 to 5 for each sandwich needed. So do you want another? Okay, this one is basically, it's called loop. Okay, you can see here, this is loop. Okay, decision usually goes down. Okay, but loop usually go up again. Okay, this one is basically a loop. So do you want another one? So repeat step 2. So you trace back where is step 2. This is step 2. Yes, go here. And no, eat the sandwich. So this is the output. So you can see here, this is the input. Eat the sandwich is the output. So you have to use parallelogram. And so you can see here, this is good example of the flowchart. Okay. So I hope you can understand how to draw this. Okay. Okay, this is another example here. ATM machine. Okay. So, okay, let me check first. Sorry, it hang. Okay. So algorithm for ATM machine. You can see here, insert the bank card and get the password from the user. So start. So it should be insert bank card and get password. Okay. If the password is invalid, display error. Okay. Is password good? Okay. So don't need to copy all the text. Okay. Just put a simple text. Is password good? Okay. Or password correct? Yes or no? If no, go to step 6. Okay. Step 6 is ask user whether you want to repeat step 3 through step 6 another transaction. Okay, this one I think is not accurate. Okay, no need to worry. Okay, this is no. You have to give the error response. Okay, and okay, if yes, get the amount. Okay, so you can see here, get the input, get the type of transaction and the current balance. Okay, you want to know how much you want to deposit or withdraw. Okay, so get the amount. Okay, and type. Okay, type of transaction, deposit or withdraw. So if you want deposit or withdraw, okay, go here and here. Okay, and you can see here the use of connector. Okay, if you have a lot of arrow come together, you can use a connector. Okay, and then goes here. And again, it will go to the end. Okay, this one give response or error message. This is the output. Okay, see, display error message. So it will give error message or response. Okay, this is another example how to convert the step. Okay, list of step to the flowchart. Okay. Let me clear this first. Okay, we already finished flowchart. Okay, I hope you can know how to do this. There is no easy way to do this. I suggest you better to look some example, practice how to change from flowchart to the list of instruction and another way around. Okay, we take another 5-minute break. Okay, we continue with the pseudocode. Okay. Okay, we continue with the last part of the chapter 1. Okay, can you hear me? Somebody can respond?
Yes, betul.
Okay, so as I mentioned before, pseudocode is basically a programming language that doesn't follow any grammar of the programming language. Okay, it is a notational system in which ideas can be expressed informally during the algorithm development. Okay, it is loosely represent the formal language. This is used when the targeted programming language is unknown. Okay, so basically, if you have algorithm, you want to try to do some coding, but you don't know what the program you want to use, so you use some pseudocode. Okay, pseudocode is okay. So for pseudocode, of course, when it comes to pseudocode, first you have to write the procedure. Okay, so procedure. Okay, so you have to give the procedure the name. Okay, so for example, before ATM machine, ATM. Okay, just write the procedure, and then you have to write all the input and all the output. Okay. Okay, and the input is what? So for example, the ATM machine, you can see here, the input is password, transaction type, okay, TYPE type, and another one is amount. So output is the display, right? Message. Just write it, all the input and all the output. So that is how you start to program the pseudocode. Okay. So of course, after you complete this, you have to write begin. So begin is basically where you start the program. So this one is still not start, it's just to define the program. Okay, this is just to define. And of course, at the end, you have to put return. Okay. Oh, sorry, not return end. Okay. Usually end. Okay. So pseudocode usually don't have any right or wrong usually, but try to do your best to follow this one. Okay. So I give you example sequence test. This one is just a basic task. So you just write this, right? Perform test begin. So for example, A equals to B plus C. Okay. I give you a simple example here. Okay. So your input is B and C. Okay. So A equals to B, C. Okay. Let me check. Usually just comma. Okay. So A equals to B plus C, D equals to A. So this is just a sequence task. So you just write something like this. And you can see here, we have some indented, okay. Usually after we have some for, okay. Okay, for example, this begin and end, we usually indented a little bit inside. Okay, and for example, if you have for, okay, for something, for I think you don't know yet. If, okay, if, and then you have another coding, you have to indent it again. Indent one, indent two. Okay, so this is just a common practice. Okay, make sure you apply this. Okay, So you already understand the sequence. This is just a standard one. Okay, this one is the conditional, okay, decision or conditional. So you have max is more than 0. Okay, so for example, I change this to max. Max is equals to A. Okay, so if max is more than 0, so max is equals to A. Okay, so if max more than 0, okay, so you have output here positive, then output not positive. So if max is more than 0, output, okay, usually we just use this one, positive. Okay, else means that if no, else. Okay, make sure you indent it. Okay, move it inside a bit, and then output negative. Okay, that is how you write pseudocode and n. Okay, so if you have a condition, make sure you have n. You can see here. Okay, this is if, and then you have n. Okay, this is conditional. So how about loop? Okay, so loop we usually use for. Okay, so for example here, I delete this. Okay. Okay, if you have something count, okay, for example here count is 0, start from 0. You have sum equal to sum plus 1 basic plus count. So you just count equals to count plus 1. So for something that loop, you have to put for. Okay. For what is the things that you increase? For count. Okay, for this case, count is increasing. Count is from 0 until 5. 0 to 5. Okay. So count is equals to 0 to 5. So why 5? Okay, because you start with 0 and you can see here count until 5. Okay. And you can see here count increase 1 by 1. So no need to worry. Just it will increase 0 until 1. Okay. But for sum, okay, sum here is the sequence, the program. Okay. Sum is equals to sum plus count. Okay. So you can use equals or you can use arrow. Okay. Either way, I just assume it is correct. Okay, no need to worry. Either you can use arrow or you can use equals to. Okay, and then n. Either you can use n or next count. Okay. Either way is also correct. Okay, because this is pseudocode. There is no rule. Okay, no grammar for this. So you just do something like this. Okay, so this is an example. Okay, procedure integer division. You have the input n and d, and you have the result. So you have begin and end. Okay, let me make it larger. So you have a okay. So you have the procedure, the name of the procedure. You have the input here. You have the output. Okay, just define this program first, and then you start begin and end of the program. Okay, so result is equals to 0. So this one, as I mentioned before, either you can use this or just equals to. Either way is correct. Okay, it's the same. So result start with 0, while, okay, while is same as for. Okay, so for loop, okay, for loop you can either use while or for. Okay, what is the difference? let me. So basically, this is for your next topic. Okay, let me. Okay, if you use for, okay, for you have to define a parameter, for example, n. Okay, n needs to be from 0 until d. 0 to d. Okay, and you have n. E and D. But if you use while, okay, this 0 you have to define at the top. Okay, you have to define at the top. Okay, and while this one, for while you test a condition. Okay, this one, if you use for, you test for, I forget the name. Okay, so for you have a n is 0, 1, 0, 1, 2, 3, 4, 5. So you have a sequence of number. But if you use while, you have a condition. You have to loop it until n is more than d. Okay, while the n is more than d means that you loop it if the n is more or equals to d. So that is the difference between loop using for and loop using while. Okay, depend on the application. Okay, no need to worry for this one. Okay, this one you will learn in chapter 4. Okay, control flow. Okay, but you need to know how to do the pseudocode. Okay, okay so another question that is popular, you have for example, this algorithm, the list of instruction, you have to convert it to pseudocode. So this one, okay, you can see here, this is quite a popular question. Okay, you have to convert the list of instruction to flowchart and pseudocode. Okay, that's it for chapter 1. Okay, so just a reminder, next class is on Wednesday, and Wednesday is public holiday. There is no class, so we continue our class at the next Monday. Okay, so any question before I end the class? Okay, no question,
No, sir.
Okay, so make sure you join the group, the Telegram group. Any announcement, I will do that here. And make sure you save the date for the test, 21 April 2022, 4 to 5 a.m. and chapter 1 to 4. Okay, so that's it. Happy holiday, I think. 1 day only. Okay, see you again next week.
Thank you, sir.
Thank you,
Okay,
Doctor.
Yes, sir.
Thank you, sir.
Sir.
thank you.
Thank you, sir.